because message passing is useful for exchanging smaller amounts of data because no conflicts need to be avoided. Message passing also easier to implement in a distributed system than shared memory. Shared memory can be faster than message passing, since message passing systems are typically implemented using system calls and thus require the more time-consuming task of kernel intervention. In shared memory systems, system calls are required only to establish shared memory regions. Once shared memory is established, all accesses are treated as routine memory access, and no assistance from the kernel is required. The first section, shared memory systems. Inter-process communication using shared memory requires communicating processes to establish a region of shared memory. Typically, a shared memory region resides in the address space of the process creating the shared memory segment. Other processes that wish to communicate using this shared memory segment must attach it to their address space. Recall that nominally, the operating system tries to prevent one process from accessing another process memory. Shared memory requires that two or more processes agree to remove this restriction. They can then exchange information by reading and writing data in the shared memories. The form of the data and the location are determined by these processes and are not under the operating system's control. The processes are also responsible for ensuring that they are not writing to the same location simultaneously. To illustrate the concept of cooperating processes, let's consider the producer-consumer problem, which is a common paradigm for cooperating processes. Producer process produces information that is consumed by a consumer process. For example, a compiler may produce assembly code that is consumed by an assembler. The assembler in turn may produce object modules that are consumed by the loader. The producer-consumer problem also provides a useful metaphor for the client-server paradigm. One solution to the producer-consumer problem uses shared memory to allow producer and consumer processes to run concurrently. We must have available a buffer of items that can be filled by the producer and emptied by the consumer. This buffer will reside in a region of memory that is shared by the producer and consumer processes. A producer can produce one item while the consumer is consuming another item. The producer and the consumer must be synchronized so that the consumer does not try to consume an item that has not yet been produced. So let's look at bounded buffer solution. Two types of buffers can be used. The unbounded buffer places no practical limit on the size of the buffer. So the consumer may have to wait for new items, but the producer can always produce new items because the buffer has no limit. Second solution is bounded buffer. Assumes a fixed buffer size. In this case, the consumer must wait if the buffer is empty, and the producer must wait if the buffer is full. So let's look at the solution.